Hello everyone, welcome to my channel, CyberTube. Today we'll be discussing XML external entity vulnerability, different ways of exploiting, what we can actually achieve with XML external entity, and any recommendation how to prevent from XXE. So let's start. Okay. Before starting with explaining what is XXE, we should first explain what is XML. So XML stands for Extensible Markup Language. It was designed for storing and transporting data. And like HTML, XML uses a three-line structure of text and data. It's also human readable and machine readable language. XML is just information wrapped in text. So what's the difference between XML and HTML? You can see here, so you can see here, they're pretty much the same. So they have tags, both of them. So what is the difference? The difference is that XML stores and transfers data, whereas the HTML, which is again markup language, displays data and describes the structure of a website. So that's why here we can see how is displayed the data. And also, XML tags are not predefined like HTML tags are. So here, for example, we can see from. Here, instead of from, it can be cat, or heading can be dog. No matter what is it. So the tags are actually defined from the author of the XML document. As long as the beginning and the beginning and the ending are the same, everything is fine. In contrast with the HTML, where actually they have like a predefined tags. So we have the body where we have H1 for the title, P and everything. So this is predefined. Okay. Another difference is XML is case sensitive while HTML is not. So here you have to be careful for any caps or anything like that, as is XML sensitive. Okay. Apart from knowing what is XML and that it looks pretty much the same as HTML, is a markup language, we need to know what is attribute and element. An element is everything from the element start tag to the element end tag. And attributes are designed to contain data related to a specific element. So you can see here, so you can see here, that's the attribute, and you can see how it's type. And after that, we have the tags with name, Apple, size, medium, whereas the element, everything is pretty much in the same structure. So there is not a huge difference, to be honest. Both examples provide the same information, so it's really up to you, up to the author, how they want to structure and present basically the data. Okay, moving to the next slide. Okay, so a part of knowing what is XML and attributes and elements, we should know additional terminology, which again is part of the XML language, as we want to explain and understand very well the XML external entity vulnerability. So we will be talking about DTD and entities. So just 1 second, because first I want to show you this. Okay, so what is DTD? DTD stands for Document Type Definition and is used to define the structure and content of an HTML document. So what is DTD? It's exactly this. the whole document is called DTD. So the whole XML document, any attributes, comments, elements, everything is part of the DTD and it's called document type definition. The DTD is declared within the optional doc type element at the start of the XML document. That's what we can see here. Doc type, and it's optional. So there are two different entities. First, to say what is entity. They are a way of representing an item of data within an XML document instead of using the data itself. So what is the entity? This here is the entity. So we have two different entities. We have internal entity, we have external entity. The internal entity is when the entity is declared within a DTD document. So it's embedded within the document, within the XML document itself. So that's it. Here we can see the syntax. This is the entity. The entity name, in this case, is student. And the entity value, in this case, is Lara Croft. So the entity name is the name of entity, followed by its value within the double quotes or single quotes. You can see here is double quotes. Entity value holds the value of the entity name. So let's move to what is external entity. If an entity is declared outside of the document type definition, it is called an external entity. They allow an entity to be defined based on the contents of a file path or URL. That's what we can see here. So the syntax is entity name system and URI or URL. So here what we can see, it is the entity, the name of the entity here, system, and here we have URI or file path. Okay. So name is the name of the entity. In this case, student, and we have the system. It's a keyword that specifies a URL from which the value of the entity should be loaded. So here, this is not just a word, it's a keyword where we have to use in this case, okay? It's not something that I make it up. Something else to mention is the URL, and URL is the address of the external source. Again, it's enclosed within the double or single quotes. It can be either of them. In this case, it's double quotes in my example. Also, just to summarize the DTD component, as I said, this whole document is called DTD. And this document can have various things. It can have the element, attributes, and entity. This is the element. I think I've showed this in the previous slide. This is the element. So if you see this, based on the examples, we have elements. If we see the attributes, we don't have attributes in both examples. As I said, elements and attributes are the same. It's just a different way of representing the data within the XML document. And we have the entities. That's how the entity looks like. This is the entity and this is the entity. Okay. And as we said, they are a way of representing an item of data within an XML document. And bear in mind that an entity has three parts. This is very important. The entity has an ampersand, yeah, an entity name, student, you can see here student, and a semicolon. So you can't change here the name to be a different name, not student, as we know, we can see here that the entity has already been named a student. So that's how we will declare it, basically. So this is the entity. Okay, so I'll move to the next slide in this case and explain now, when we know what is XML, what is DTD, entity, elements, attributes, and all of these terminologies that are related to the XML language. We can explain what is XXE XML external entity. It is a security vulnerability that allows a threat actor to inject unsafe XML entities into a web application that processes XML data. This is how it works. So the hacker is checking to see if the website that they're hacking basically parse XML data. If it parses and if the parser is vulnerable, they will try the external entity, only the external entity, as you can see, to exfiltrate data. Okay? And what attackers can do? Threat actors that successfully exploit the XXE vulnerabilities can interact with application server itself and all systems the application can access, so any backend or external systems. So if this server, let's say this server is vulnerable, the attacker managed to exploit the vulnerabilities. If this server is somehow related or has trusted relationship with another server, the attacker will be able to also retrieve information from the other server. So this server will request information from the other server on the behalf of the attacker. Okay, what causes XML vulnerabilities? They are caused by XML parsers, as I said, if they are outdated or not properly configured for applications that use XML format to transmit data between the browser and the server. So here the case is XML parser. What is the impact of the XXE attacks? First, disclosing local files. Once you do this is data theft. This would lead to reputation damage, which is not so good for the companies. We have also remote code execution and gaining access to other servers on the network, as I mentioned here, if the server has a trusted relationship, and performing a denial of service attack. Okay, so XML external entity types of XXE attacks. So we have basically a few types, or probably like we have a few ways of exploiting and what we can do when we exploit the XXE vulnerability. We can retrieve files, we can perform SSRF, which is server-side request forgery. I'll explain how it works and what is it. And we can also exploit blind XXE to exfiltrate data. This is out of band. If you want to know more information about blind technique, any out-of-band techniques, you can also see my other video. Okay, in this slide we'll be discussing the XXE exploit to retrieve files, but before showing you this slide, I want to jump on my virtual machine Kali Linux and show you how actually I retrieve files using this XXE exploit. Alright guys, I'll be using port your test lab web security academy and exploiting XXE using external entities to retrieve files. This page snow delivered to your door. This is nearly Christmas time. Okay, so here we have Paris. Let's go for London. I want to check the London stock unit, so 480 units. Okay, and I sent a post request. This is the post request. This is the last post request that I sent. I'll go to repeater and let's see the post request. Okay, let's send. That's what we can see here. 480 units and 480 units. That's how the server responded to us. What else we can see? We can see that this website is using XML for storing data. So we can see here it says XML. We can see the structure of the XML. So this is XML. It looks like XML. It smells like XML. Well, it's XML. So we will try in this case to see if this website is vulnerable to XML. So I'll be using an entity. Let's grab one from here. Oops. Okay. Let's just quickly grab this one. All right. So I'll just copy paste it. We already explained this. What is doc type? And it's not necessary. This is the name of the doc type. The entity, this is the name of the entity. System, as we said, this is the keyword because we'll be extracting from the system, and the file path. And we're aiming, if the website is vulnerable to XML external entity, to be able to see the etc password file. All right. So what else we can do? We should basically write the XML entity here, and we said that it consists of 3 elements. The first one is the ampersand. Second one is the name of the entity, which is XXE in this case, and followed by semicolon. Let's send this to the server, and what we can see is vulnerable. We're getting invalid product ID. Yes, it's invalid because there is not such a product as this one. But we're getting also the password file, which is great. It means that the web application is vulnerable to XML external entity. Okay. Alrighty. Now this was the video for how XXE exploit in order to retrieve files. So this is very quick recap. Post request, as we see here, we identified that this is XML, so that's why we're trying to see if it's vulnerable. And for example, we use London in this case. We use a different city to check stock. So send a post request to the server. This is the post request product stocked, and the server responds with the units. Currently they have 908 units from this city for the particular item that we're querying basically. And payload used in the post request, we just tried to add this payload, which is a doc type hacker. The entity is attacker in this case. I name it attacker. That's why I run the entity as attacker to retrieve the password. And then we can see that the server responded, even though the server responded with 400, which means bad request. It means that it's customer error with the 400 status. It's also responded with the etc password. So how does it work? Basically, as we saw, this attack can retrieve an arbitrary file from the target's server file system by modifying the submitted XML. So we modify the XML, and the attacker, by introducing the doc type element, when we define the external entity that contains a path to the file, in this case is the etc password. All right. So the next slide is XXE exploit to perform SSRF attack, which stands for server-side request forgery. It's a web vulnerability that allows an attacker to cause a server-side application to make requests to unintended location. So basically, the attacker targets any applications that support data imports from URLs or allows them to read data from URLs, and that's what we can do with the external entity, of course, if the application use external entity and parse XML. So exploiting XXE vulnerability. the attacker needs to define an external XML entity using the URL that they want to target and use the defined entity within a data value. So that's the example. In this case, it's pretty much identical like the previous one. So we have the doc type, we have the entity, which in this case the XXE system, where we'll be accessing using the system. And this is the website in our example that the attacker actually wants to access. So see, there are basically two types of SSRF. The first one is backend, and the second one is server attack. So this will be the local one, and the backend. It's mean that the server actually has a trusted relationship. So the application has a trusted relationship with some backend servers, and I will show you an example what I mean by this. Alright guys, so we're back in my virtual machine, and we'll be using this example, the basic server-side request forgery against another backend system. As we are discussing the backend system, and we will see how actually we can retrieve information from the backend system. So this is the web application that we're going basically to hack. So I just picked up this item, couples umbrella. So let's use the Paris one, check stock. Okay, and what I can see here, this is the request that I've set. Let's see, 284 units. Let's see what's the response, 284 units. So this is the post request that I've just sent. And now I can see here stock API. So in order for the website to retrieve this information, the website communicate with this IP address here, this internal IP address here. We can see that this is URL encoded HTTP. This is column / / / this is the IP address. Here again, you have, this is column 8080, which is the port. And after that, you have /product /stock. So %12 means /check, and so on. So that's the URL where the web application goes in order to expose us, show us this here number. Okay, so what we can do here, because we can see it's 01. I will send this request to intruder. Let's go here, and now we clear it. Okay, and now I will just add number 1 here and go to payloads, and the payload types will be number. As now what we'll be doing, we'll be sending basically request from number 1, as this was the IP address, and the internal IP range starts with 1, 2, 255 will be the last IP address that we want to send the post request. This is absolutely the same post request. We want to try sending it among like the whole internal IP range from 1 to 255 and see what will happen. It will start from number 1, and I think we're good to go. So I'll start the attack. Okay, that's fine. We need here the we use the demo version, but that's okay. It will still work. So what we are doing here, we are sending absolutely the same post request, and we are trying to see if the web application actually is communicating with other IP rather than the one that we saw ending on .1. So now we're basically enumerating from 1, .2, .3, .5. That's what we are doing. So we can see here for .1, it's the status is 200 OK, because this was the initial request that we saw, that the web application was reaching out to 129.168.0.1. So basically for the rest of them is 500. So I'll just assume that the web application, it's not communicating with any of those. You can see here, oops, just very quickly do check. Until we are waiting. Okay, be okay now. So you can basically check by statuses from here. Currently we have only 200. So basically we have to wait to this to reach 255, or just see any other communication with different IP addresses. So I'll just click on again and just keep updating. Oh, there you go. So we have here communication. Even though it's returning 404, this means that, so a status that starts with 4, it means that is a customer error, so it's coming from me. This means that we basically sent a wrong request. So this request doesn't basically exist. We can see this IP address .110 responded with not found. Okay, but looks like there is some kind of communication here. So I will send this request to the intruder, actually repeater. Okay, let's send again the same request. Yes, it's not found. All right, now I will delete this, our initial query, and I will leave just the IP address with, we can see here HTTP, the IP address column 8080 / and I will just add admin, as I want to see if we'll be able to open the admin page. And that's what we can see, 200 OK. And we can see some information about the admin. Okay, not solve, home, admin panel, admin. All right, my account. Okay, we've managed to open the admin page. You can see here admin delete username, okay, 2 different usernames being deleted. Let me just beautify this, because I want you guys to see what is this exactly, and I'll just copy paste it here using this tool to beautify it. Okay, and that's how it looks like. So this is the page that we've managed to open. So 2 users, delete. That's great. We have basically access to the admin page. So that's how basically it worked. We've managed to get access to a different application that was a backend application that was actually communicating with the current site web application that we're trying to hack. So this is the trusted relationship, and this web application had a trusted relationship with this backend server, and normally the backend server because they're backend server and they're within the internal network and they're not supposed to be publicly available. They have very weak security posture, and that's what we can see. So we've managed to get the admin information. Actually, this web application managed to get the admin information on the behalf of us, so on the behalf of the attacker. Okay, great. Let's move on to the very quick recap on what we've done. So we discussed the backend server-side request forgery, as we said, the web application, like the server. So the server that's behind the web application has a trusted relationship with the backend component. In our case, was the one ending on 110. So what we did here, we basically replaced the stock API. So we replaced this post request to something else that we basically want to see if the backend server was basically vulnerable and whether it will it will show to us the admin page. So now the next attack is server-side request forgery attack. That again, I'll first show you how it's done. Alright guys, so now we'll be showing the second type of server-side request forgery against the server itself. So the application has a trusted relationship with the server that basically hosts the web application itself. So we'll be using this site. Here from the Web Security Academy, as you can just notice, here we have home, my account. I'll just pick one item. Let's go with the giant piloting. All right. So I will send the request. Okay, this is the last request. Let's see what we can. Here again, we have similarly to the example with the backend server, we have a stock API. So this is basically the request that the web application is sending to the web server itself in order to get this result 152. This is the response as well. That's the response. Okay. So what will happen if I just change? Sorry, before this I have to send it to the pizza. I should be able to make any changes. So here basically we can change it to whatever we want. I will change to a local host. This means that the server will send a request to itself. That's the local host loop. So I'm sending the response, and here's what we can see. Oh, sorry, I forgot. Slash. Okay, and now that's what we can see. Let's render it and see how it looks like. Okay, can you see the difference? Here we have home, my account, from basically from the external IP, and here when the web application make a request or the server to make a request to itself, we can actually see admin panel. So that's the difference. Great. If it's admin panel, let's see if we'll be able to access the admin page. Let's see the response. Oh, great. So this is the raw response where we can see Okay, admin delete username, admin delete username. That's what we can see here. So this won't be clickable because it's just like the rendering showing the pages, what we should normally see. Well, not the user. This is just probably the admin who can actually operate on the server. So what I will do, I'll just copy paste this here. Oops, and see what will happen. Oops, response, congratulations, you solved the lab. Okay, that's what we did here. It's sending 302 found, which means that the request has been redirected, which is like a good sign. And basically we solved the lab in this case by sending this. So that's how basically it works. This is the server-side request forgery for attack for the server itself when we're using like the local host and being able to access different pages from the server itself. Okay, so let's continue. Just a quick recap on this. So the server-side request forgery attack commonly exploit trust relationship within the server itself, and the attacker induces the application to make an HTTP request back to the server that is hosting the application via its loopback network interface. That's what we actually did using the local host, but you can use the corresponding IP 127.0.0.1. Similarly to the example with the backend, we just changed the stock API URL here. In this case, we concentrated working only on the local host because we wanted to show the attack based on the server itself rather than a backend server that has a trusted relationship with the server that hosts the web application. And we've managed to solve the lab by deleting one of the users. All right, let's continue. So why attackers use the SSRF attack? Most of the time is because bypassing firewall protection, and I will explain you and show you how this works. So we have an attacker, web application, and the corresponding web server. So what does the attacker do? Thus, the attacker tries to access the internal server by sending a payload. Here, they want to access the etc hostname. Okay. What is happening? The firewall is blocking the request straight away because it's an external IP address. So what the attacker will do, sneaky, will try to access the public server, and if the public server, so the web application, is vulnerable to XXE and basically parse the query, it sends it to the server, the internal server, and then the internal server respond to the crafted request, sends it back to the web application, and the web application relays the results to the attacker. So what is happening here? First, we have the external IP address, the attacker one accessing the server and being blocked, internal server, and that's why the attacker is trying to access the public server, and the public server is sending requests to the internal server, working on the behalf of the attacker. So within the works, we will not see any interaction with this IP address, but we will see this web application requesting this payload or for path requesting to the internal server. So that's why the firewall will be bypassed, because this internal server trusts the web application without knowing that the web application is vulnerable to this particular type of attack. Okay, and next slide. Okay, so the next slide is blind XXE vulnerabilities. As the name says, blind, what is supposed to be, the application is vulnerable to XXE, but doesn't return any indication that the application is vulnerable, so it doesn't return any indication of success within its response body. So in this case, you have to pay attention to some behavior of the server that basically hosts the web application itself. So how this works, we're using Burp Club again to intercept the traffic, and imagine that we had absolutely the same examples. We have a web application where we can basically pick one item, and we can see the request within this item, and we can see on the referral the Web Security Academy. So here, instead of being this request, what we'll do is change the referrer address to be one of our Burp collaborator domains. So this domain here, http blah 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 .burpcollaborator.net, is the attacker domain or our domain. So what we're trying to do is to redirect the traffic, so basically to cause an outbound request from the targeted web application to ourselves, as we want to know if basically the web application is vulnerable to blind XXE, and if it's vulnerable, the web application basically will perform an outbound request to us. In this case, you can see this is the request. When I sent, I can see the response is just like the logo. It's the normal page. So there is no indication of success on the normal page. But what happened actually when I check my Burp collaborator, I can see this request. These are the outbound requests. You can see here the collaborator server received a DNS lookup of type A for the domain name. This is the same domain name. So what we're seeing here is that we're receiving outbound requests. We're receiving requests from this server. So the targeted server is reaching out to us, meaning it's vulnerable. We can't see any indication here, but we can see the request. And normally, if you're seeing this from like a blue team perspective and you're checking like the data packets, you will see the external IP address. You will see the outbound request. So you will see the web application reaching out to the Burp collaborator, and the Burp collaborator then will reply to with some characters and just with 200 OK, just saying like, yes, okay, I received the request, and this is the indication of success. Okay, so pretty much this is like for the blind XXE vulnerabilities, but they can also be exploited to retrieve data, so via error messages or via exploiting vulnerabilities, in this case such as shell shock. If you like to see some examples of error messages and exploitation of the shell shock, you can go to Port Swigger and just play around with the testing lab. I will leave a link in the description for this. Okay, and now let's move to the next slide. Okay, external entity prevention. So the first thing that you have to have is web application firewall, and this is just best practice, and it will massively decrease the chance of external entity vulnerability, but not always. So you also need to configure the XML parser to disallow custom DTDs or document type definitions. The next one is configure the XML parser to disable the external entity functionality. So the external DTDs are meant for use by trustworthy parties, but threat actors often exploit this legacy feature to attack web applications. You can disable DTD to prevent XXE attacks. However, if you cannot disable this, you can still mitigate this risk by disabling the external entity functionality. This will ensure that the parser doesn't automatically resolve external references when processing input. The next one will be input validation and output encoding. So input validation ensures that all inputs supplied to the XML parser is well-formed and doesn't contain any malicious code. Output encoding ensures that any data retrieved from the XML document is properly escaped so that the browser cannot execute it. The next recommendation is whitelist and DNS resolution. A solid approach to avoid server-side request forgery is to whitelist the IP addresses or any DNS names that your application requires access to. You will see in the next suggestion, disable unused URL schemas. If your application is solely reliant on HTTPS or HTTP to initiate requests, permit only these URL schemas. By disabling unused URL schemas, you deny attackers the ability to utilize the application to carry out requests via potentially harmful schemas, including dictionary and the file path. You can see in the previous examples from the slides and from the VM how we actually reach out to backend application using the file host, the admin page, or the file host host names, or the file etc password. So if this URL schema has been disabled, this will prevent any data leakage, basically any data exfiltration. So this is the last suggestion. Okay, and I think this was the end of the video. Thank you so much, guys. Thank you for watching. I hope you liked the video. Please subscribe if you did, and please share, like, and comment. See you.